Hey everybody, hopefully you're enjoying your summer vacation just as much as I am. I took this chance to record this podcast even while I'm on a roller coaster. So hopefully where you are, you're having as much fun as I am. And then we'll get to the podcast here in just a minute. Woo! All about solutions. So what is a solution and so on. This is one type of mixture. Mixtures can be really big particles like this called suspensions. It's made up of really large particles in a solvent, usually water, and they're too large in order to stay dissolved. So they spin around and then they settle down to the bottom. There's also two other types of mixtures. There's a solution and a colloid. Let's see if you can figure out which one's which. The one on the right is a solution. And the one on the left is a colloid. That's correct. Now, which one has the smallest particles? Again, the one on the right has the smallest particles. That's what the solution is. The one on the left has medium-sized particles that actually diffract light. That's why you're being able to see the light pass through the one on the left much better than the one on the right. So the one on the left is called a colloid, and colloids can be in the air like fog. Colloids can be a liquid dispersion, kind of like this Jello water right here. And colloids can also be a mixture of air and liquids, like a foam is. Whipping cream is probably the best example of that, and it's probably worth doing some homework on that. So get yourself or get your parents to get you a can of that whipped cream and just spray some in your mouth. Just think of it as learning chemistry by eating. Suspensions, really big particles. Colloids, medium-sized particles. Solutions, small particles. We say that liquids are miscible or immiscible based on whether two liquids will come together or not. Okay, this is an example of line dry. This is a chemical that will actually take water out of gasoline. Now, water and gasoline are typically immiscible, meaning they don't mix together. Water is polar, and the other one is non-polar. So what this does for you is gives you the ability to bind one end of this molecule, of this isodry, binds to the gasoline. The other end of the molecule is polar and binds to the water, and this allows the two immiscible substances to actually become miscible again. You guys need to know all this vocabulary. As far as rates of solutions go, you need to know what are the 3 ways to make solutions happen faster. And I call it the sweet tea rule. The sweet tea rule is, how do you make sweet tea? Well, do you use big lump sugar or do you use tiny sugar? Tiny sugar, because particle size matters, right? Surface area. So you want the smallest particle available. Do you just let it sit? Or do you stir it? You stir it, of course. When you stir it, it agitates it. That's the second rule. And number 3 is the temperature. Most things, not all, are more soluble in hot solutions than they are in cold solutions. You would want to start with hot water if you were making sweet tea, not with cold water. So you need to know those 3 things that affect the rate of dissolution. Typically, the higher the temperature is, the more soluble something is. Typically, and that's for solids, and for gases, the way it works is the lower the temperature is, the more soluble it is. So where are some of the best fishing grounds in the whole world? They tend to be in stormy, cold seas. So in the Atlantic, for instance, there are lots of storms in the North Atlantic, and it's very, very cold water. And so with that cold water and with the agitation of the wave action in the wind, that generates lots of dissolved oxygen in the water. So you tend to get greater abundance of fish, not more species necessarily, but more fish per unit of water than you do in warmer waters. The colder it is, the more soluble a gas is. The warmer it is, the less soluble a gas is. Pressure has no effect on the solubility of solids, because pressure can't squeeze solids any smaller. It does have an effect on the solubility of gases, though. So make sure you get down in your notes that the higher the pressure, the more soluble the gas is. And this is true because it makes the little gas bubbles smaller. Increased pressure means less volume. And since they're smaller particles, they will dissolve better. When we write an equation for dissolution, if I ever have you do that, it is very, very simple. All you have to do is take the ions and split them apart. So for example here, I start out with solid calcium chloride. And when you put it in water, it forms one calcium ion, shown there, and 2 chloride ions, shown there. So 1 molecule of calcium chloride will produce 3 ions. So if I had 1 mole of calcium chloride, I would make 1 mole of calcium ions and 2 moles of chloride ions for a total of 3 moles of ions. This is very, very important, especially in the next chapter. So just make sure that you understand that you could take 1 mole of an ionic substance and come up with more than 1 mole of ions.